Well, I want to introduce you to a good friend of mine, Craig Kolodge. And Craig and I go back, way back. How many Stormwater Awareness Weeks have we been doing, Craig, together?
Oh, I'll bet it's close to 8 to 10, somewhere.
Yeah, maybe close to the beginning, right?
Yeah.
Stormwater Awareness Week has definitely grown. We started with just as a regional event, and this year we have people from 26 states joining us, 4 different countries. We have about 2,600 registrations and about, I think about 800 unique individuals. So it's really grown, and we're so excited. Craig has been a favorite of many, many people in his past workshops. And of course, always talking about his #1 passion. Well, maybe #2, maybe his wife is #1, but #2 passion, compost-based BMPs. You can't have a conversation with Craig and not talk about compost. So I want to give Craig as much time as possible. So again, if you have questions, put them in the chat. But Craig, it's all yours.
Well, thank you, John. I appreciate it, and really appreciate the opportunity to share, as you said, my passion for compost, because it truly is. And what we're going to be doing today in the next hour is I'm going to be covering the topic of compost-based BMPs, best management practices, for those, and that includes all of us really, because we're all part of some city or jurisdiction here in the state that are basically tasked with meeting new organic diversion goals that were implemented through a bill. It's a law called Senate Bill 1383, the Short-Lived Climate Pollutant Act, that was passed in 2016, became effective in 2022, this year in January. And we're going to cover that. I'm going to give you a quick overview just so you understand, because everybody's going to be impacted by it. If you haven't heard from your waste haulers or what have you in your jurisdiction, in your city by now on starting to recycle your food waste and that, you certainly will soon. I want to just point out the photograph I show you here is actually composted mulch in a sock system, a sock containment system, creating a sediment trap, a pyramid, literally. These are socks that have been stacked on each other, and we're going to show how they built that with blower trucks. And that is holding back I think it's actually almost more than 3 feet of sediment coming down. If you can't see to the right of the photograph, but there's a mountain there. And this amount of sediment was actually flowing into an apartment complex. And we built this here in San Diego some years ago. And it was, believe it or not, this was the impact of a 1-inch rain event. It just shows you what can happen when you have really erosive soils. So we're going to be talking about various ways to address that using compost. And we're going to move now to the next slide. Let's see, make sure, there we go. Let me start by quoting somebody that I have a really high regard for. His name is Jerry Gillespie. He's out of Australia, and he's been involved in the compost and waste management industry for many, many years. He wrote a book recently called The Waste Between Our Ears, published in 2020. And in that book, he wrote, while climate change may be the largest threat we have brought upon humanity, the lifting of carbon levels in soils, increasing moisture infiltration, and the opportunities for change that it brings could be one of the greatest shifts humanity has created since the start of the Industrial Revolution. This new direction is based on the simplest and most disregarded of the byproducts of humanity, our organic waste, in all of its forms. Our ability to return organics to our soils must be driven by regulations. It is too important to rely on goodwill alone. And that really underlines why the state of California, in their effort to address growing climate changes and very unpredictable weather patterns, why they implemented Senate Bill 1383, because they felt this is an existential threat to our survival on this planet, and we've got to take some action. And we start by taking action when it comes to stormwater management and compost by understanding how natural stormwater is actually managed through a series of layers of organic matter that are a natural process of decomposition. You know, you have the leaf litter, the needle litter, the pine trees will drop. A lot of people don't realize it, but evergreen trees, they're dropping their leaves all year long, where a deciduous tree drops it all at once in a short period of time, but they're all contributing organic matter consistently and constantly to the soil surface upon which they depend. And if you look at this picture, it's one of the slides that was introduced to me by a Dr. Britt Fawcett, who's a very dear friend and is the technical director for Filtrex International. And he always pointed to this slide as kind of capturing why compost is so important and how it works in a natural system. And so what we do in a stormwater management situation or scenario is we try to mimic this. We try to mimic nature. And Dr. Fawcett actually did his PhD and is, in my opinion, the world's leading authority on the use of recycled organics, organic matter, as it relates to the management of stormwater. And he's done tremendous research, tremendous amount of outreach. And this is probably one of his favorite, if not his favorite slide, to show people exactly what's going on when we apply organic matter, why it is so absolutely essential to stormwater management. Now let's take a brief pause to cover a little bit about Senate Bill 1383. Organic waste comprises more than a third of California's waste stream, and if you include paper and cardboard in it, it's even greater. And so if you look at that pie chart there, you can see it's a very large part. Now, why it's so critical is when you treat your carbon in the form of organic feedstock, if you will, as a waste product and bury it in the earth in landfills, it produces a chemical molecule called methane. And methane, for those of you who aren't aware, is 25, I've even heard higher numbers, 25 times more potent in holding atmospheric heat in our environment, resulting in really escalating and adding insult to injury. We've already got too much carbon in the environment due to our burning of fossil fuels and hydrocarbons, and then all of a sudden we take our organic material that can be used in so many other and more beneficial ways and we bury it. Well, those days are quickly coming to an end. And the demand for recovered organic waste products is now driving the infrastructure investments. So you've got the collection, you've got the recycling and recovery process, and you've got the procurement of what is produced through this process of recycling and recovery. And then you have the end use, and that's what we're going to be talking about more today. I'm just going to, if I can't, there we go. On the bottom, it says procuring recovered organic waste products is vital to closing the loop. The loop is, they're talking about is the circular economy, which includes everything that's a part of what we consume and what we manufacture and what we do with our planet and the resources we have. Next one here. Oh, for some reason it's not advancing. Let me
click on the slide, Craig, and then try it, or use your arrows.
Okay. There we go. So the demand for these recovered organics products come in the form of mulch. In the case of Senate Bill 1383, they typically refer to a non-composted mulch. And then compost, you see a photograph there of what we typically think of compost, but actually compost can be used very effectively as a mulch. And we're going to talk a little bit about that as it relates to meeting those requirements. And then renewable fuels, renewable electricity, renewable heat, and electricity from biomass. We will not be covering those. Those are other components of Senate Bill 1383 that you'll be hearing more about. But today we're going to focus just on these. The one thing you have to realize about renewable fuels, even if we were to process all of the organic waste we have right now, it would represent a very small percentage of the fuel that's necessary to drive our economy. And so even though it's an option, Largely, Senate Bill 1383 is going to be about mulch and compost and what we do with it and how we manage it. Now, mulch and compost have to be eligible to be go towards the mandated compliance requirements for Senate Bill 1383. The mulch must meet and exceed the physical contamination, maximum metal concentrations, and pathogen density standards set by the state and by the local jurisdictions. It has to be produced at one or more of the following permitted facilities: a compostable material handling operation like San Pasquel Valley Soils, where I work today, or a facility other than a chipping and grinding operation. The reason chipping and grinding operations do not fall under an eligible mulch is because they typically are not part of the waste stream that goes to landfill that produces methane. Meaning, to address that, that material typically is left on site during the course of a land clearing operation. So it really would help us in reducing the amount of organics going to landfill if we were just to focus on that. So that's taken out of the equation. It also applies, the mulch can come from a transfer processing facility or transfer processing operation or a landfill. Then the compost also has to be produced at one or more of the following permitted facilities: a compostable materials handling operation or facility like, again, San Pasquel Valley Soils, or a large volume in-vessel digestion facility that composts on site. So those are your options. Let's look a little bit more closely at mulch, because mulch can be used as an extremely effective filtering media in a sock or even in a berm to filter stormwater. And when they talk about it here, they're talking about it as it relates to the actual laws that govern the quality and the specifications of the material itself. The mulch shall meet the following conditions for the duration of the applicable procurement compliance year as specified, and they cite the sections, and this is all done through the state and to the local jurisdictions. So because of that, the jurisdictions have enforceable ordinances or similarly enforceable mechanisms that require the mulch to be procured by the jurisdiction to comply with these articles. And that includes testing mulch for physical contamination, maximum metal concentrations, and pathogens. So you have to be a little careful with non-composted material that has not gone through a pathogen reduction process, which all permitted compost facilities are mandated to do. Meaning that a non-composted mulch, wood chips, even if they're coming from a permitted facility, must go through these standards and meet the local jurisdictions' enforceable ordinances. And I will tell you for a fact that most permitted facilities don't go through these testing requirements. And so it's going to be very hard to find a composting facility or anybody that actually has gone through this testing. So that leads us to compost. Compost means the products resulting from the controlled by biological decomposition of organic solid waste that are source separated from the municipal solid waste stream, or which are separated at a centralized facility. And in the process of biologically decomposing this material, we heat the material up, thereby making it safe to use and eliminating pathogens like E. coli, fecal bacteria, and weed seeds. And therefore, compost is the organic material of choice when it comes to the two options. Now, if you look at the procurement of recovered organic waste products, it's based on the jurisdiction's population. So, for example, the San Diego region's population is 3,351,000 roughly residents. And they apply a per capita factor of 0.08 tons per individual. So that would mean if you multiply 0.08 times that population, the San Diego region has a procurement requirement. The jurisdiction target to utilize and process 268,143 tons of raw organic waste. So the procurement target is based on the total raw organic waste that is then processed either as a mulch non-composted or as composted going through this biological decomposition. So now look at that conversion factor for products. And then go down to that green arrow where it says mulch, 268,143 tons. What they're saying is the conversion factor, because the mulch is not composted, is 100%. So it's 1 ton for every ton of raw organic waste, meaning it's not broken down. When you take this raw material and you compost it, you actually lose a good almost 40% of it through the decomposition process. Therefore, you can actually use less compost to meet your raw tonnage procurement requirement than you can mulch. Meaning, if you use compost both as a mulch and as a soil amendment, and we're going to show you a number of different uses for it, you actually need less of that material to meet your compliance requirements of tons of raw organic waste that are diverted. So that results in the amounts of recovered organic waste products. And compost is your best bet, okay, for the biggest bang for the buck, okay? Now you can utilize these recovered organic waste products, both compost and mulch, in a number of different ways. And here I just list a few. We're going to talk about a few more here as we get into the discussion. You got city parks, you got landscape center divides, you got roadway and construction projects. You have erosion and sediment control of slopes and areas where soil has been disturbed. You have green infrastructure, which is the mimicking of nature to vegetate something similar to what that landscape looked like before you denuded it of vegetation. And we also have city-hosted compost and mulch giveaways and other means of using this material. Now, an example of this is the San Diego Sustainable Landscape Guide that, oops, sorry, let me go back. This guide is the watershed guide for managing watersheds using, in this particular manual, this guidelines using recycled organics, mulch and compost along with cardboard to eliminate turf areas, things like that. And they guide the residents of San Diego through the process of how to create a sustainable landscape in a climate challenged environment. And the way they do that is by actually working with the county, and the county actually will pay people to get rid of their lawns and utilize compost. My neighbor just did it. She got from the county water authority $1,800 to remove her lawn towards the purchase of organic compost to create a sustainable landscape that was drought tolerant, very minimal amount of water being used using natural landscape products and trees. So these are just some examples of how that works. And the procurement options, you have direct procurement, which is compost for city managed and commercial landscaping. The jurisdiction can procure recovered organic waste products directly for use or giveaway. They can procure it for erosion and sediment control and green infrastructure. And they can also procure it through their relationships with the waste haulers, landscape services, and transportation services. All of these are avenues for people to start to gain control and use of recycled organics and start to use them beneficially to minimize global warming as well as to manage stormwater management and the quality of our air. Procurement does not necessarily mean purchase. That's an interesting comment, meaning that sometimes the jurisdictions can recover material and they may have, for example, a jurisdiction, the city may have their own composting facility, and therefore they're not having to procure it from some third party. And so they can actually utilize, in fact, Orange County, I think, built 2 brand new compost facilities simply to be able to get around having to procure it from outside sources. And this can be a paper transaction, and there's no requirement for a jurisdiction to utilize their own compost that they produced They can take compost from other jurisdictions and utilize it to meet the procurement requirements, as well as they can sell or make accessible compost coming from their jurisdiction available to other jurisdictions as well. So there's a lot of flexibility on how compost gets moved around and tracked. And one of the main requirements of the new bill is to actually keep records of what you're procuring and how you're maintaining these records and using it. And that's through CalRecycle and to verify your compliance efforts. So when we look at, let's say, California, 1.5 million tons of compostable organics that used to go to landfills and are now going to be diverted, that translates to 3 to 4 million cubic yards of compost and mulch as recovered products. So that's a lot of material to divert. And big question you have to ask yourself is divert where and how? Well, water quality, erosion control, and the landscaping sectors play a major role in this. The current and potential compost and mulch sales, if you look on the left there, is relatively small, 621,000 cubic yards, not anywhere near what we're going to need to do. Now, if you look at the total potential sales of 1,521,000 cubic yards, that's where we need to get to. That's where we need to go. And that's why we're talking about this, and that's why all these cities and jurisdictions in the state are going to be wrestling with this requirement. So let's get now to compost and compost-based management practices that will help us meet these goals. First of all, these uses of compost align with climate action plans and comply with state requirements. They improve the stormwater quality and reduce erosion. We're going to talk a little bit about how they do that. They significantly reduce runoff volume because compost, half-inch minus the fine compost, will absorb a tremendous amount of 4 gallons of water per 1 cubic foot of fine compost. That's how much it'll hold. So if you can absorb water, do you have a runoff volume if you absorb all that water with a compost mulch? You don't. Once you control the runoff volume, you essentially control the erosion and the sediment that move with it. Nutrients and pollutants are decomposed by naturally occurring microorganisms. Our ability not only to capture stormwater, but to basically clean it up and filter out pollutants in that stormwater is so critical to the quality of our environment. Then you get into the carbon benefits, which is really at the crux of Senate Bill 1383. The use of compost BMPs encourage healthy soils, which ultimately results in sequestering or storing this carbon in the soils themselves. So we can take it out of the environment. It can be taken up by plants and by all the organics that we use, and we can sequester and store it and move it into the soil where it will be safe and not continually impacting the atmospheric environment that we're trying to manage here. Promotes establishment of vegetation. That alone also sequesters some of that carbon in the growing vegetation. And it improves the soil structure and nutrient content. Better plant health, reducing the need for chemical fertilizers, pesticides, and herbicides. If you got healthier soils, typically plants will not be as vulnerable to the effects of pests such as fungi, bacteria, nematodes, etc. And you don't need to use the pesticides, therefore you reduce those. And you can use some of these organic materials as well as a mulch in place of herbicides.
Craig, we got a question I think that relates to this. Someone's asking, where is the compost and mulch tested to make sure bacteria or other constituents are not present? And is this done at the facility that processes the mulch?
That's really an excellent question. It's actually, there's a program through the U.S. Composting Council called the Seal of Testing Assurance. And they have a relationship with soil labs around the state. The one we use here in California almost exclusively is Soil Control Labs out of Watsonville. And they are a certified laboratory. And there is a process of testing the soil to meet certain criteria that give you all the information you need to be confident that your compost does not have these pathogens. They test for weed seed viability. They test for germability of the material, its stability, and they give you an entire breakdown of the nutrient characteristics of the compost. So when you participate in an SDA program, and most of the composters, at least that I work with, and our own organization, we send in on a regular basis our compost for testing. So when someone asks, you know, I'd like to know what's in your compost, I can actually send them a soil test result from a certified lab. And that this goes on through anybody that's participating. You cannot participate in the seal of testing assurance without that test. Now, there are some composters that do not participate in the SDA program, but they do test their compost through other certified labs, like Wallace Labs out of Los Angeles does a very good job. And so there are other means, but the U.S. Composting Council's SDA program is a good source of information on whether the compost you're purchasing has been thoroughly tested and vetted, if you will, for the quality that it will provide. Hope that answers your question. So with this next slide, notice we have two materials here. One looks like a mulch and one looks like compost on the right with the circle on it, doesn't it? Well, actually, they're both compost. To get the growing media, the finer material, we usually call it 1/2 inch or 3/8 inch minus compost. That's done by screening a combination of fine and coarse material. When you grind up your green feedstock, you get a wide variety of different particle sizes. Some of them are large, 2 to 3 inches. Some of them are very small. To produce what we call a growing media, we screen this mixture, and the coarse material, what we call the overs, goes towards the use as a landscape mulch or a filter media. So we can filter stormwater through coarser material, has more pore space. We can grow and support vegetative growth. And it also filters somewhat, but primarily it's used for supporting vegetative growth or amending the soil and increasing the water holding capacity of the soil, as well as the organic content of the soil. And we'll talk a little bit about the importance of organic content. Compost applications. So recycling and low impact development movements. Well, we all know about recycling, but some of you may not be familiar with what low impact development is. Low impact development is trying to return landscape that's been disturbed, that has bare soil or disturbed soil, back to its original state as much as possible, so we have the least amount of impact on that soil surface. And that's called low impact development, or green infrastructure is what the EPA refers to. There's a number of terms for it, but the bottom line is you're trying to get that soil to support vegetative growth. And so both of these work hand in hand. You've got your local recycled materials. From that, you create your certified media, both coarse and fine. And then you've got containment systems for moving this material around, or sometimes just applying it loosely as a mulch. And we're going to talk about that. And then you've got the results, and the data there is absolutely solid when it comes to the filtering and restorative properties of these recycled organics as it relates to stormwater. And there's a lot of research, and we're going to show you at the end of this presentation where you can go to get that data. So compost erosion control blankets, that's one people hear about and they don't know what we're talking about. They're thinking of a blanket, and what we're talking about is that growing media being used as a mulch. Okay, so remember I said compost can be used not only as a soil amendment and to grow and support plant vegetative, but it can also be used as a soil erosion control blanket. And it's usually blown on large, and ideally, when you apply it through a blower truck and blow a layer, usually 1 to 2 inches maximum, you can add seed to it, ideally native seeds. And if you can vegetate it either through natural rainfall or irrigation, There is absolutely no competition for that as the very best erosion control you can have, period. A vegetated layer of plant material, ideally grass, because there's a very fibrous root system holding that soil in place. And here's a picture of grass growing in a layer of compost, a compost blanket. You can see in the top photo, they're blowing that on a slope, and oftentimes it has seeds in it. And once the water hits it, those seeds germinate and they lock that blanket in place and hold that soil beautifully, where you get virtually very little to no erosion. Erosion is the detachment of a soil particle from the soil surface, simply put. And it differs from sediment in that sediment is what has been detached. So when you have sediment, you are already detached. So ideally, we want erosion control. If we don't have 100% erosion control, then we want to capture that sediment. And compost can do both for you. Here's an example of how little you need in a compost erosion control blanket in terms of thickness based on 24-hour rainfall totals of 1 to 4 inches. And it just shows that the very slope angles from the least steep to the greatest elevation, steepness on the bottom, the 2 to 1, you can see that even a half to 2 inches is all you need of this fine ½ inch minus to 3 inches minus compost to hold that soil in place. If we're on a slope, we can add coarser material to the fine material to help retain it on the slope. And there are other means. We're not going to go into all of them. There's lockdown netting. But ideally, a 1 to 2 inch layer of compost is all you need to create a compost stormwater blanket. And we're now going to look at some case studies on compost. I say compost and mulch utilization. In this case, I'm referring to mulch as a compost mulch, not as a woody mulch. Okay, as a woody non-composted mulch. Okay, so here we go with a project that I think is one of the most striking examples of compost that was evaluated in a 2-year study by Caltrans up in the Monterey Bay area, around Prunedale area, if you know that area between Monterey and Gilroy. And what they did is they used compost blankets, a layer of the fine material, and berms, and they compared it to hydromulch and hydromulching and BFM and fiber roll applications. This slope here, believe it or not, is what happened when they applied compost BMPs on the top of the slope, and on the bottom they went with conventional bonded fiber matrix, hydromulch, and straw wattles. And it was a 5-inch rain event in a highly erodible soil in 1 day, 24 hours, 5 inches. And in this case, they didn't use the mesh to hold it, they did berms. And you can use a sock is literally a portable berm. If the sock holds that composted material in the sock, and you can move it around and it keeps it from washing out. In this case, they chose to vegetate the blanket and the berms with seed and just blow it on with a blower truck. And here's another example of a berm on the left and how you can use these berms even in place of silt fence to filter stormwater. Typically, we like to see the berm made up of the coarse material, what we call the filter media, the overs, the 2 to 3 inch, so we can allow that stormwater to go through that mulch and be filtered out. But as you can see from that earlier slide I just showed you here, we got virtually no erosion or movement of that soil under that blanket. And we got severe erosion and even a loss of the integrity of the straw wattles to slow that water down and prevent deep rilling and channeling of the soil. It was just quite amazing. And Caltrans has this presentation available for those who are interested. Some of the resources I'll be showing you at the end, particularly one from Cal Recycle, will have that presentation available if you'd like to see the actual results of the 2-year study. So Compost, when used as berms to filter stormwater, is extremely effective. It can also, the finer material, the blankets can be vegetated and be used for creating filter cells, vegetated bioswales, all of them very effective at not only removing sediment, but pollutants and vegetating and preventing erosion. So in the Caltrans study, what they discovered was compost retained a large volume of water without the movement of that blanket. It prevented and reduced the real erosion. You saw the photograph. It reduced runoff volume. Remember I said if you can absorb the volume of water and hold it in that organic material, you don't have a runoff problem. And it promoted the establishment of vegetation, which really locked in that soil. Compost improves the downstream water quality by retaining and adsorbing pollutants. The surface of this organic carbon allows pollutants to attach to it, and then the microorganisms in nature will actually degrade and in many cases even decompose the pollutants themselves, like hydrocarbons, oils, diesel, gasoline, things like that. It'll tie up heavy metals. It will consume, believe it or not. A lot of people think compost blankets contribute to nitrogen, and they can if you don't use the right compost and you don't follow specifications. But more often than not, compost blankets and berms and socks will actually lower the amount of nitrogen, phosphorus in the runoff, as well as capture oil and grease, fuels, and pesticides and herbicides. Extremely effective at cleaning out pollutants in our stormwater runoff. And also in the same token, when used as a mulch, that will break down and improve the soil's underlying soil structure and nutrient content, reducing the need for chemical fertilizers, creating these healthy soil biology. The compost-based BMPs remove as much or more sediment and pollutants from stormwater as traditional perimeter controls such as silt fence. Silt fence and even straw wattles filter very, very little. I'm not saying that you can't get water through them, but it's almost negligible. And therefore, you're depending on that barrier, that physical barrier to hold that sediment back and not either rupture or become damaged on a storm event. The compost also allows a larger volume of clear water to pass through it, as we talked about. Here's an example of the compost blanket compared with jute and vegetated soil, which worked very well with straw netting and just bare soil. And because of all this, what Caltrans has done over the years is continue to utilize and increase the utilization of compost for stormwater management, soil management, vegetative management, a whole list of benefits that they have come to become dependent upon. And they continue to increase the amount of usage because they are a part of the solution of Senate Bill 1383 and certainly a source for diverting organics. So let's go to socks here real quickly and talk about them and how is compost applied in a sock system. Well, it can be blown in on site or it can be pre-palletized. And so you can actually purchase the material, filter socks and grow socks with the growing media in it. And we're going to show that in a bit, where you use the fine growing media in the sock system to stabilize severe erosion control situations. So here are some examples of restoration applications using compost socks. So we have that fine material in the upper left, and we can mix seed in with that material and put it in a sock, and then we can create a fascia or a layer of sock and anchor it to the severe slopes and vegetate that slope while using that geotextile mesh to stabilize that root system and that slope. So here's the mesh. Typically, it's a 1/8 to 3/8 inch opening. You can fill it with, again, the fine material or the coarse. If we wanted to just filter sediment, I would go with a coarse material, the filter media. But in this case, we're going to be talking about green infrastructure and trying to get something to grow and stabilize that soil underneath that sock. Polypropylene, it's typically photodegradable when exposed to UV radiation in 2 to 5 years, but once it becomes vegetated, and covered by vegetation, it can almost last indefinitely because there's no UV damage to break it down. It becomes pretty much permanent and provides extreme durability to the slope and to the severe eroded area. Comes in different colors, patterns, and what have you. Here's an example of a case study in Carmel Valley that I was a part of, where we used slope interception or what they call slope interruption devices, used to use or still do use extensively straw wattles or filter rolls. But more and more, we're going to start seeing compost filter socks used. Number one, this was a 100-acre project. 50 acres were treated with BMPs, and they utilized 1,376 cubic yards of compost, a nice amount. The installation cost, because they blew it in place, so the sock was created in place on the site, was about $191,000. The net savings to them in reduced maintenance and repairs, because they just cut the sock after they were done and left it there, or they picked it up and utilized it on other projects, was about $130,000 compared to comparable conventional BMPs. The carbon benefits to this were 890 metric tons of CO2 equivalent and $190,000 in environmental public health benefits. So there are some really good financial reasons why you want to be looking at these options. It comes in a biodegradable, these socks do material mesh as well. Here's a project Caltrans did. In this case, they used a growing media in it, which I don't typically recommend with a biodegradable sock because the bottom will rot out very quickly with any amount of moisture. And here's what happened. You can see the sock started to rip and tear on the slopes. But what was nice about it was they just cut the sock when they were done. As they came in and started landscaping, they just layered the compost there to support the vegetative landscape material and just left the socks in place. They never removed them. So if you're going to use a biodegradable mesh, make sure you apply it to an area where you never want to pick that sock up and use it again. It's going to stay in place and it'll become part of the landscape. It'll also, if you've got severe slope erosion, it's not going to give you the tensile strength that a polypropylene mesh will give you, such as this situation here, where you've got a steep bank along a stream. You've got some riprap. You've got the polyethylene sock wrapped in a geogrid to anchor it into the slope, and then you've got vegetation growing into it. This will eventually be completely covered. You will not see any of that when it's completely mature. It'll look very similar to this. You can even live stake them, but these become extremely stable BMPs for stream bank restoration in severe slopes. So here's some examples, and I'll show you where you can get some information on this, on how you anchor these socks in with using GeoGrid to wrap the socks with the growing media and putting the sock seed in it. Here's an example, part of it, the lower portion being wrapped in GeoGrid with the upper portion just being stacked on top with growing media in it. And there's what it looks like after the vegetation takes hold. And I'm going to go through the next slides fairly quickly to wrap this up, just so you can see examples. Here's another slope stabilization project with seed in the sock itself and what it looks like when it's fully vegetated. Here they're doing, on the right, they layered it into the slope, the stream bank, I should say, and on the left, I did actual transplants right into the sock to vegetate it with a riparian species of plant that they wanted to grow in that. Here's a severe slope up in Northern California. This was actually in the Gilroy area. It was really affecting there were some salmon that were running in this creek. You can see the creek on the bottom. This is how they were trying to manage their erosion. This is another example. They covered the creek up so they could start to stabilize that and grade that slope so they could start to layer the sock. So here they are grading the slope. Here they are bringing in grow socks. That's the growing media in a mesh in small 3-foot sections that they could carry up and then wrap it in GeoGrid and anchor it onto the slope. And there in the inset, you see what the slope looked like after they did irrigate this up. They wanted to get that vegetation growing as quickly as possible. Here's what it looked like a year later. Here's one high wall project that was just amazing. This was a quarry. So this is just literally rock. This has very little to no, it's 400 feet in height. The people blowing about a 1 inch, ½ inch to 1 inch layer with native seed to this slope had to hang on halters. It was 7 acres to severe slope. They used 964 cubic yards of compost at about 1 inch depth. We trialed alternative BMPs, but they failed on the slope. The cost of this was about $52,000 to blow it on there. Projected water savings was greater than 10 acre feet, and the carbon benefits, 630 metric tons of CO2 equivalent, were sequestered on this slope, and 130,000 in environmental benefits. And you can see on the right there again the vegetation after it took hold in the background there on the right. Here is a burn site in San Diego, the Lilac fire. This was literally a mobile home park that took all the mobile homes out. These people lost everything. On the right, you can see the mobile home was rebuilt after a year later. We just I threw some native seed on there with a 1 inch layer of fine compost. I used the socks to just on the toe of the slope and on the crown and in the middle, just to slow the water down so I didn't get any concentrated flow moving my blanket, my compost vegetated blanket. And there's the native seed growing, stabilizing that slope a year later. So you can see restoration remediation applications are really, really a untapped resource here in California as elsewhere. There's a lot more we can be doing with this material, and I just wanted to show you a few examples. You can even create living walls with it. But the next steps, and this is a call to action to really get people to better understand how to use this, is communications and training to staff and contractors on operational, environmental, and economic benefits of using compost, similar to what we're doing today. And to become engaged and promote updates to address erosion control and water quality project specifications using locally produced compost and mulch. Then to quantify benefits of potential projects using a full cost analysis through use of tools and case studies to demonstrate economic and environmental value of the best management practices. And lastly, to collaborate, pardon the misspelling there, it should be an A, collaborate, with local colleges and horticultural erosion control training programs like Stormwater Awareness Week to share information on these practices. And now I'm just going to go through a few resources and we'll open up like the last 10 minutes for some questions, hopefully. There's the Sustainable Site Design Manual that has 24 compost-based BMPs. Dr. Britt Fawcett and Rod Tyler and Alex all contributed to the development of this non-proprietary Sustainable Site Design Manual with 24 different projects, if you will, or uses, applications would be a better word, outlining what you need to know to be able to utilize compost to create sustainable sites. And where you can get this manual, you can get it through the stormwateruniversity.com bookstore. They carry it there. Or Filtrix International. They are the, in my opinion, the premier compost BMP innovators in the United States, thanks to the work of Dr. Britt Fawcett and Rod Tyler and others. And you can go to their website, filtrix.com, and you can download all the design specs that are in the manual at no cost. It does have the Filtrix logo on it, so if you're a public entity, you want something that's non-proprietary, then you're probably better off going with the the Sustainable Site Manual. But in this case, all the designs, the CAD drawings, can all be found on their website. Beautiful resource, tremendous service to the stormwater industry. And here's one of my all-time favorite one-stop shops for all things involving compost and mulch use. It's the Compost and Mulch Use Toolbox on CalRecycle's website. Go to that website, Google Compost and Mulch Use Toolbox for CalRecycle, and it is loaded with links to all kinds of research and information on how to utilize compost and mulch, not only for stormwater management, for soil health, for agriculture, you name it, it's all there. And then there are tools to quantify benefits, and it's really important when we start justifying the cost of our BMPs to be able to quantify what benefits we're driving. And these are some sources. A big one is the Comet Planner, and they utilize a number of, it's put out by the USDA, a number of soil tests for measuring organic matter in the soil and calculating the amount of carbon that's being sequestered. But there's also CARB, the California Air Resources Board, and they have a benefits calculator tool on organic programs. You have the US EPA waste reduction model called WARM, and then Greenscapes, which is also associated with the US EPA. So a lot of good tools here. And then you have on the Cal Recycle's website, you have procurement calculator tools and model procurement tools, just a wealth of information. So with that, I'm going to stop. I've kind of done a whirlwind tour of compost BMPs, and I'll open it to questions, John.
All right. Well, thank you, Craig. As always, quite informative. So we do have a few questions that I wanted to cover, and if you have any questions, go ahead and type them in. I think this one you were answering even as they were typing it. Are there any alternatives to polypropylene socks because of the problem with photodegraded plastics? What is the risk with the polypropylene? I actually, while you were talking, found an article by the government suggesting that polypropylene was actually could absorb a certain amount of PFAS.
Yeah.
What have you seen as far as alternatives or maybe the negatives of using polypropylene?
Well, Filtrix makes a biodegradable sock, the natural that's made of a biodegradable material. Beyond that, you're really stuck with either polypropylene or polyethylene. Filtrix makes two different types of, or a number of different types of sock, different size diameters, whenever, depending on the specifications of the project. But here's the deal. The mesh itself is a component of the system, meaning what's doing the work really is what's in the sock. And that you can leave that on site. You can cut the sock up and remove the polypropylene so you don't leave it in the environment. You can remove it and leave the compost to do what compost does, which is degrade and enrich the soil. And if in the case of the mulch, it'll actually continue as a berm. Once you're done, you can actually cut the sock, remove it, and leave the berm there, and it will still function. It's still very functional as a stormwater filtration device or application. Now, you've got the sock, and there are, believe it or not, like in the Southern California, there are like 23 polypropylene recyclers. But here's the catch, and this is what makes it difficult. They only want to recycle clean plastic, right? So after you've used it, so unfortunately, that component of the system, the mesh itself, if you take it and remove it from a job site or from a landscape site after its functionality is done, or you leave it there because it becomes part of the green infrastructure, either way, if you leave it there, there's no problem. But if you're removing it, now you have a disposal problem, and that, unfortunately, at this time, has to go to the landfill. I think at some point there may very well be services that take spent polypropylene mesh, polyethylene mesh, and clean it so that it can be recycled. Here's the sad thing about the mesh. It is recyclable. You can make other products with it. You can repurpose that material. It's just we haven't gotten to the point in the economics of it to make it worthwhile to collect the polypropylene, the plastic mesh, and actually clean it up and recycle.
Right. Well, and speaking of economics, that kind of is our next question. What kind of full cost analysis do you use in calculating the cost of the compost? And is there a tool that they could use? Is there an online tool?
Cost of compost. Well, first of all, compost is not a single product. Okay, there are many different kinds of compost. Not all compost is created equal. That's why the specifications are so important. That's why the testing of the compost has to occur, and why you need to have transparency. And so every composter also will, due to their feedstocks and what have you, the feedstock determines the quality of the compost. So I always say there are no two composts are created equal, but they'll be pretty close. Particle size becomes more critical when it comes to using compost as a BMP. And I think that'll be the biggest challenge that you have in terms of sourcing compost. But cost-wise, it's going to vary. It's going to vary. Our composted mulch that's non-screened, that has both the fine and the coarse before we screen it, $8 a cubic yard. And that's pretty much, 5 to 8, maybe 10, it's fairly reasonable. It's not expensive. The finer material, because we have more labor and cost in it, that may go for anywhere from, $14 to $15 a cubic yard for the growing media. And if there's things added to it that it's a customized blend for somebody, let's say you add some nutrients to it, then it may even go up as high as $20, $25 a cubic yard. So yeah. Every compost is going to have a little different twist on what they're offering the public. The things that I always check for is, has it been tested? Does it meet the criteria, the specifications for the state to be used as a compost and as a mulch? And I would say after that, then it's a matter of just shopping around and developing. One of the biggest challenges of compost also is transportation. It's heavy material. So you're better off if you can source your compost as close as possible to the project where it's going to be delivered, or your transportation costs will go right through the roof.
Yeah, we actually purchased 2 tons of compost for our construction sandbox, which we'll be featuring on Thursday of the Stormwater Awareness Week, and it was $50 for the 2-ton load.
Yeah.
So it's fairly reasonable. Now let's flip that on its head and look at the other side of economics. And we only got a couple minutes to address this. Probably could have a workshop just on this. Are there economic incentives for using compost, such as you have these Senate bills, you have these government mandates, these laws? Are they incentivizing it economically, like tax breaks, rebates, or grants, so that it is expensive to lay down a compost blanket?
Yes,
I wanted to do that on several projects, thought it was totally worthwhile, but when they look at the dollar figure, they balk.
Yeah, really good question. And yes, there are grants, CDFA, but mostly it's right now it's associated with agriculture. They're leaning heavily on agriculture to take the load of the materials, and but that requires transporting the material to the farms. And many cities don't have farms right in there. Los Angeles, there just aren't a lot of farms in LA. So if you're going to move material, you're going to pay a fortune to move the material to a farm. But there were $67 million in grants issued by CDFA this year to use compost in combination with cover crops for a 3-year rotation just for this year. And there'll be another 67. So there's a lot of money in agriculture. There are some rebates through an organization called Zero Foodprint. Believe it or not, an organization started by chefs, award-winning chefs who want to do their part to recycle food waste from the restaurants. And what they do is they take donations through the public and crowdsourcing.
Crowdfunding,
yeah. And they take money and they offer, but again, they're focused primarily on farms. We're trying to get them to focus on landscapes and watersheds. But what they do is they will fund the cost of transportation, which is usually the biggest cost, towards the transportation of the compost to the farm, where the farmer then can apply it. And so he'll pay this modest fee for the compost, and Zero Foodprint will pick up the cost of actually shipping it.
Well, Craig, it's been wonderful, but unfortunately we're out of time. So if people want to get a hold of you, how can they get a hold of you? Do you have a slide there? All right.
Thank you for reminding.
Take a quick picture of that with your phone if you want to get a hold of Craig. Also, this will be uploaded onto the Stormwater Awareness Week website. There's a recording of today's workshop. So thank you, Craig. Thank you to all of you who attended this workshop. We hope you can join us for some of the last ones. And don't forget to catch some of, watch our 3 keynotes. The second one, where river meets the sea, we'll present tomorrow. And I think you'll not want to miss that one. It's on the Carquinez Bridge and the Carquinez Strait. And we're featuring the executive officer of the San Francisco Regional Water Quality Control Board. So I think you'll really want to see that. All right, well, thank you, everybody. See you at a workshop tomorrow.
Thank you, John, for moderating.
You're welcome.